In this lesson, we're going to talk about the most important unit in all of chemistry, and that is the mole. The mole is a counting unit. It is very similar to other counting units that you use every day, such as dozen. The word dozen means 12. Gross means 144. Pair means 2. Well, the mole also means a number. It means 6.02 times 10 to the 23rd, and we call that Avogadro's number. The mole is the SI unit for how much of a substance we have present. So for elements, that unit will be atoms. For compounds, especially covalent ones, it's molecules. And for ionic compounds that are in a lattice, formula units is what we will be counting. Just to get an idea of how big a mole is, it is a massive number. As you saw from the previous slide, it was 602 sextillion things. Well, if we had 602 sextillion marbles, then those marbles would cover the surface of our planet 50 miles thick. An enormous, enormous amount of things. Well, why do we even need the mole or a unit to count with? Well, it's to make comparisons in chemistry. Not every element, not every compound has the same size and mass. They're all different in their own way. So when we want to compare the masses of reactants to do a reaction, we have to know more than just the mass. We have to know the exact number of things that we have to line up to do a reaction. It's impossible to get the mass of an atom or a molecule because they are way too small for any measuring device we have to measure. So to get the mass of an atom or a compound or a molecule, we have to gather a lot of them in order to register. So we eventually decided on the mole, and the mole, think of it as the number that you would eventually have to accumulate to get 1 gram of protons or 1 gram of neutrons together. So then scientists decided that carbon-12 would be the atom, the specific isotope that everyone would use as a standard. So in carbon-12, you would have 6 moles of protons and 6 moles of neutrons, and then that would add up to be 12 grams total. Now once you have things in moles, you can make these comparisons, and now you're comparing apples to apples instead of apples to oranges. Like, for example, when you have 1 mole of salt and 1 mole of elephants, well, they are vastly different things, but now you can at least compare the sizes because you are comparing the same number of things. As I teach you to do mole conversions now, this slide becomes very important. You may want to stop, print this slide out, and keep it in your notebooks as a guide. Let's begin by converting between moles and representative particles. And our tool, if you look at your mole map, our tool to do this will be Avogadro's number. So starting out, and I'm going to use dimensional analysis to teach this. At the end of this presentation, you'll see a couple of slides that will present you with a couple of different methods. You decide ultimately which one you prefer, but I again will teach you dimensional analysis. In this problem, we have 5 moles of aluminum. We know that Avogadro's number tells us that for 1 mole, or in 1 mole of anything, we will have 6.02 times 10 to the 23rd things, and since aluminum's an element, that's atoms. So we do the math here, and we calculate that there will be 3.01 times 10 to the 24th atoms of aluminum. Now to do that, if you go back and look at what we've done, we started with 5. This is multiplied by Avogadro's number. So it's really looks kind of complicated, but it's as simple as saying 5 times Avogadro's number gives us the number of atoms, or how many things. On to example 2. if we have 21 moles of a compound called copper 2 chloride, I give you the formula there in parentheses, it contains how many formula units? All right, so this is a ionic lattice, so there will be a lot of stuff there. So the formula units would be the simplest network, the simplest piece of the network, which is CuCl2. Well, we're going to set it up the same way: 21 moles of copper 2 chloride times moles on the bottom. In 1 mole, so we want moles to cancel, in 1 mole there are Avogadro's number of things, and this time formula units. So we do the math. Again, it's a multiplication problem. We get 1.26 times 10 to the 25th formula units. Now example 3 is going to be just a little bit different because we are starting with molecules and we want to go to moles. So 4.37 times 10 to the 21st molecules. So we set up our conversion factor now. Molecules are on the bottom. This time we're looking for moles, so moles will be on top. And Avogadro's number will be on bottom. So this is a division problem. And the answer for this one comes out to be, to the proper number of sig figs, 0.00726. And the unit is moles. Well, when we're converting between moles and the number of representative particles using Avogadro's number, it's pretty easy because the conversion factor will always be the same. It's always Avogadro's number. Well, it's not quite as straightforward with mass. If we're converting between moles and mass, we'll be using the same factor. In this case, the factor is going to be something we call the molar mass. The molar mass is a gram per mole, the amount of mass in 1 mole of any substance. The bad part is that it changes for every substance. Every substance has a unique molar mass. So we'll be using the periodic table to calculate this molar mass for each problem. Example 1, we start out again with our 5 moles of aluminum. Okay, so our conversion factor, if we start with moles, moles has to go in the bottom, grams will be on top. For aluminum, there are 27 grams in every 1 mole of that substance. I got the number 27 from the periodic table. So this becomes a math problem. We multiply 5 times 27 and rounded to sig figs, 135 grams of aluminum. Elements aren't so bad because, again, you can just look at the periodic table and get the molar mass. In example 2, we've got to do a little extra work because copper 2 chloride, you can't just look it up on the periodic table, you have to calculate it. So we will do that real quick. So for copper 2 chloride, we go to the periodic table and we look up the molar mass for copper. It's 63.4, rounded to the tenths place. And for chlorine, it's 35.5. Now for chlorine, there are 2 atoms in the formula, so we'll multiply that by 2. And we will get the total sum to be 134.4 grams per mole. And we'll use that number in our conversion factor. So as we set up the problem now, we have 21 moles of the copper 2 chloride times the conversion factor. Moles will go on bottom, so that will cancel. And the molar mass will go on top, 134.4. Another multiplication problem. And the answer, rounded to the proper number of sig figs, is 2,800 grams. Then for the last example, example number 3, we're going to go backwards, and I'm going to start you out with 64.8 grams of the CO2. As we set up our conversion factor, grams are now on the bottom so that they can cancel, and we're looking for the moles on top. 1 mole of carbon dioxide. Well, from the periodic table, we know that carbon is 12, and we know that each oxygen is 16, so the molar mass of CO2 is 44 grams per mole. So that will be our molar mass. This time we have a division problem. 64.8 divided by 44 gives us, rounded to the proper number of significant figures, 1.47 moles. Okay, so in class we'll do plenty more examples, and you'll get proficient with it then. But for now, I want to show you or make you think about it in a different way. I want to stress that doing the math here is important, and of course you have to know how to do the math. But what's really important is that you understand what you're doing. You are converting from one unit into another, and the math is simply the tool that you use to get that done. So I want to get kind of maybe out of the math mode a little bit and get away from these conversions, and I want you to think about this as something maybe you're more familiar with. Think of these conversions as analogies like you would see for the SAT, or maybe you've done these in English class. If we take the same example that we just got through doing for aluminum going to grams, and we think of it first as a ratio or an analogy, 5 moles is to 1 moles, as what number is to 27? Again, this 27 is unique for aluminum. But if you think about it, and even set it up as a proportion, 5 is to 1 as x is to 27. Well, in solving for x here, this becomes something you've done a lot of in math. You cross multiply, and you get x equals the 135 number that we got on the previous slide. If this makes more sense to you, then you have my permission to do it this way. Another example, if you go back to the 2 slides ago when we first looked at moles and using Avogadro's number, we have 5 moles is to 1 mole, as what number is to Avogadro's number? Again, if you set that up as a proportion, you will get 5 times Avogadro's number, and you would get the same 3.01 times 10 to the 24. If this makes a lot of sense to you, you may want to select this method. And finally, this video, which is on the last slide on the PowerPoint, is a link to a YouTube video. This guy is going to show you how to do it. Maybe you don't like proportions, maybe you don't like dimensional analysis. If you like taking the mole out and just knowing whether you need to multiply or divide, then this guy will go through it and show you how to do it that way. Again, pick the way that best fits the way you think, perfect it, and then we'll see how you do in class.